Okay, I see that no one else is in the waiting room, so I think that we should start with the webinar. So, first of all, thank you everybody for joining today's event, for joining today's webinar titled the ELEC Replicability, Scalability, and Market Opportunities. The event will last more or less an hour, and we will have a chance to interact with major representative of the project eNeuron, who will showcase us some of the, let's say, methodological activities that have been implemented in the process of the evaluation of the key exploitable results of a project that in the 4 years of his lifetime achieved many results that partially will also be covered today. And without further ado, I would say today's webinar will start with Salvatore Fabozzi, researcher from ENEA, who will give us a very general and broad overview in the few time that we will allow him to speak of the eNeuron project. Following this will be Dimitrios Lagos, project engineer and PhD student at IREC, who will go through, as I said, the main topic in a certain sense of today's webinar, the replicability and scalability process of evaluation of the project exploitable result. Finally, we will have Francesco Noera, a colleague from Icons, a social innovation officer, who will conduct a brief, let's say, survey in which we will ask you to be actively engaged, providing a sort of feedback on what has been said today during the webinar, as this will be very essential also for the project, in a certain sense, to evaluate from a standpoint of the people interacting with us, interacting with the project, what is your opinion and how even the project might implement and improve in the, at the very end. So having said that, there will be also a final Q&A session. So if you have any question or doubts, please maybe write them down. At the end of the webinar, we will give you the floor to express your doubt and interact directly either with Fabrizio, Francesco, or Dimitrios, depending on your question. And yes, I think that having said that, I leave the floor to Salvatore Fabozzi so he can give you a brief overview of the project, what it is all about. So thank you very much.
Can you hear me? Yes?
I think
can you
can.
hear me?
Yes. Yes,
yeah.
properly.
Okay, I share the screen. Can you see my screen?
Yes, perfectly.
Okay. So, I am Salvatore Fabozzi from Italian National Energy Agency for New Technology, Energy and Sustainable Economic Development. And I wanted to welcome everybody to join this meeting, this webinar. And I want to share something about this webinar is for give you some insight about the replicability and scalability strategies of the project. And but of course, I will give you an introduction of the eNeuron project and the concept behind this project, and the idea of the project, and some of the layout that we have developed in these years of work. First of all, I wanted to give you an overview of the project. So, Green eNeuron project means for green energy hubs for local integrated energy community optimization. The project lasts for 4 years. We are currently at last year and last month. And to this project join 18 partners for 9 European countries. And we have tested all our solution on the 4 different pilots across the Europe that assure a high complementarity with each other. Another thing that I want to show is the idea of a eNeuron project. For eNeuron project, what is the meaning? What is the idea under this project? It's to develop an integrated tool for the optimal design and operation of integrated local energy communities by integrating the distributed energy resource and multiple energy carriers at a different level. But we want to that this tool has 4 different different objectives. So we want that not only take into account for both technical issue, but even for economical and environmental priorities / objectives. And we want that this tool consider the stochastic approach for day-ahead and real-time scheduling. So in particular, it's important because probably in the energy community, the stochasticity is one of the main features that we have. We want to foster the peer-to-peer energy trading in order that even the prosumers can sell electricity at local energy level. And we want that all the different actors will be involved and will be even not in conflict with each other. So I want to stress even the attention about one word that I have utilized in this first word. So the word integrated. The concept of integrated local energy communities and what it consists. Integrated means much more than an energy community as stated by the European Commission. And in particular, I want to stress the attention that integrating for us and for the eNeuron project means looking of how effectively to integrate the carriers, such as a variety of local generation of heat, electricity, flexibility, flexible demand, energy storage, and electricity mobility. We want, for integrated, we means that we want to facilitate the cross-sector integration at the local level by integrating the smart energy, smart grid and demand-side management technology with the help of the conversion technology that now we have that can facilitate the cross-sector integration. And we want to support the grid by providing ancillary service and flexibility. All these new concepts lead to some advantages that we can summarize in some points. We can have an increased efficiency through the interplay of carriers. We have a higher RES penetration, and we can reduce the need of reinforcing the grid. So this new concept is in integrated. We can summarize that we have developed these tools based on on the design phase and operational phase, and we can summarize the objective that we want to have and we have. So we have the long-term design optimization of a multi-carrier local energy system. So this is for identifying the optimal architecture of such system that we want to analyze in terms of optimizing the configuration alternatives through a multi-objective approach to account for both technical, economic, environmental priorities and objectives, as I said before. And another thing that we want to do optimal daily operation of the integrated energy system through stochastic approach, as I said before, and the simulation of the peer-to-peer energy trading to investigate the feasibility of convenience of the optimized scheduling strategy for the prosumer point of view in a local real-time market. All these characteristics led to a main question. So, how can I plan such a system? How can I analyze it from an operational point of view, and how I can finally control it? So we have the idea of eNeuron is based on three layers of functionalities. So we have the planning phase, the operational phase, and the asset control. Each of these layers focusing on different stakeholders and needs. So we have the planning phase with the system design and the expansion planning, for example. And we have the operational analysis, for example, to validate the system design that we have done in the previous layer. And another thing that we want to, and then we have even at real time, so at the building level, the real time control and monitoring of the consumption, for example. All the layers must be in collaboration with no conflicts each other. So if someone of the actors use one of these layers, could use even the services of another layer, but with no conflict with each other. So they are matched each other. And we use an hybrid approach. So from top down to bottom up operate in the operational phase. So we can analyze the system starting from the building to the local community, or starting from the local energy community going down to the building. So I want to give you only an update about the service that we can, and the target user that we can have in each phase, in each layer that I have summarized before. So for what concerns the planning phase, where, as I said before, we can have the service of system design. But system design, the service that we can have is the cost optimal expansion planning for a given structure. So if we have just a community already done, we can have the cost optimal expansion, cost optimal results. Or another service could be cost optimal expansion plans for a new structure. So if we start from scratch, if we don't have an energy community, but we want to build. And then we have another service in this phase that could be the cost environmental planning for a new structure. So if we want to have the trade-off solution between the cost and the environmental for a new structure. The target user for this layer is for sure distributed system operator, local energy community manager, energy cooperative, and local authorities. For what concerns instead the operational phase, the service that we could have in this phase, we could have scenario generation for operational system analysis. So if we have done in the previous layers an analysis from the scratch of a new energy community, we can have the generation of a scenario, and we can analyze how it works, this new system that we want to analyze. Then we can have, even for a service in this layer, the cost environmental, they had the scheduling for different scenarios. And I wanted to underline that in this phase, we can have both deterministic and stochastic approach, as I said before. And the target user for sure could be local energy community manager and energy cooperative. But for what concerns instead the real-time and asset control layer, the services are input-output for the real-time operation of the microenergy hub. Remember that microenergy hub, in our case, should be considered the building in itself. And then the other service is monitoring the peer-to-peer energy sharing, as I said before, because we want to foster the peer-to-peer energy trading market to sell electricity abroad at the local level. And for sure, the target user in this case should be end users, aggregators, ESCO, and local energy communities, only for monitoring in this case. Future impacts and future direction. For what concerns the impact of our tool, it's for sure enhanced energy efficiency and the reduced greenhouse emission. And we can give a contribution for sure for the European decarbonization goals. And for future perspective, we want to, for example, investigate the emerging technologies. And I mean not only the technologies of conversion, the conversion system technology, but also the technology for what concerns new algorithm that we can utilize in this sense, or new technology for the demand side management. And even adapt the solution to different region and sectors. And so I think that in this case, we'll give some insight, my colleague from IREC that will explain to you something about the replicability and scalability of our eNeuron project. So I have given the introduction of the eNeuron project. If you have then any question about the project, you can ask me, or you can go on the eNeuron website, or you can write me an email, or to the other my colleagues that can answer you. So thank you to everybody.
Thank you very much, Salvatore. Thank you very much for this overview of the project. I think that now we can leave the floor to Dimitrios Lagos and his presentation. So thank you, Dimitri, for joining. The floor is yours.
Hello. Yes. Thank you very much, Davide, and thank you very much, Salvatore, for your complete introduction of the eNeuron project. I'm sharing my screen now. You we should be seeing it.
Yes, we can.
Can you please confirm? No? Okay, perfect. So, hello everyone. My name is Dimitris Lagos, and as David said kindly, I'm a researcher in Catalonia's Energy Research Institute in Barcelona. So today I'm going to talk about eNeuron strategies for replicability and scalability, and we're going to talk about the general framework that we used in eNeuron, the eNeuron project, and the concrete methodology that we followed at the end. So the agenda of today's presentation starts with the introduction and basic notions of scalability and replicability. Later follows the methodology and actually the framework that we used were based onto, which was the bridge framework that was adapted for our project needs. Later, we're going to follow with to depict the evaluation process and the results and the representation. And finally, we're going to conclude our today's presentation with the best practices for future implementation and mention, of course, bottlenecks in this procedure and give the overview. So let me begin with the basic notions. After all, sorry. Yep. Okay, so what is scalability and replicability to begin with? So replicability of a project solution or a system would be to be able to apply this the proposal, the project or the solution with the same effectiveness without having limitations of the place. Which could be like a country or a region and stuff like that. And then to be followed by scalability, which would be the scalability of a system, would be the ability of a system to be applied in large scale without losing its desired properties and without increasing a lot, at least, its complexity. So the goal of the scalability and replicability analysis is to evaluate through a consistent methodology some indexes that are related to these two notions about which are scalability and replicability, namely. So in one line, like very briefly, eNeuron's approach was actually the intention, like we tried to evaluate our key relevant key exploitable results in terms of scalability and replicability indexes across the different layers of the smart grid architecture model, which is a common model about smart grids that I'm going to highlight later its importance to this procedure. And to do this effectively, we need to ensure the high quality of our methodology and its consistency. And most importantly, we need to follow a flexible framework that can be adjusted to the necessities and the particularities of the analyzed project while maintaining the robustness of the methodology. And also this helps to follow a robust framework can also help to the comparing different analysis between various projects. So let's go on with the framework that was used for our project. To begin with, I'm going to briefly mention the basic steps that are indicated in Bridges framework that has been discussed last years. So to begin with, the Bridges framework indicates that we have to start our analysis with subroutine 1, which is the mapping of the project objectives into the smart grid architecture model. After care identification and evaluation needs to be done, which will be later connected with the relevant KPIs identification and evaluation. And after these two evaluations, the results of the analysis and the limiting factors should be mentioned and analyzed and shared, of course, with the community, within the community, via best practice approaches and limitation factors of the approach and the solution in itself. So the most relevant steps, subroutines, if you want, that were followed in eNeuron's scalability and replicability analysis were 1, 2, 4, and 5, while the KPIs evaluation, identification, and evaluation was also taken into consideration, but in a different task apart the main, let's say, the core scalability and replicability analysis of the project. So to have a clearer image, here you can see the most important adjustments that we did in order to adapt and take the best out of Bridges framework. So we adapted this framework to fit into the necessities and the particularities of eNeuron project. So in the left-hand side, you can see Bridges framework with subroutine 0, which was added, which is like blurred, and you can see it added in the right-hand side in the neuron process with some changes. So also there was a small change, like the finalization of the project objectives in order to be able to make possible the evaluation of the scalability and replicability with respect to the objectives of the project. So now I'm going to talk a little bit more about like step by step the steps, like each one of them that we followed. So to begin with, the purpose of subroutine 0 actually was to review. We reviewed various eNeuron-like projects and shared with them a questionnaire that was created during the scalability and replicability tasks of the eNeuron project in order to gain a lot of insights from the scalability and replicability activities that had already performed before our activities. So the most important things that we found with this small study, let's say, were common challenges that were faced in these activities, successes, and common and lessons learned from these projects. So just to give you a small overview about the questionnaire and the summary that we got out of it, was that the questionnaire was had mostly like 4 main axes, and the questions were formulated in these four axes. So the first one was the important results and the correlation with the SCAM layer that these results had. After we had like 7 questions in parentheses, as you can see, the number in the parentheses is the number of questions related to this axis. So after we asked about, we tried to gain more insight about the methodology definition, and later the dimension selected to be evaluated through this methodology. Did it have to do with SGAM model, or did it have to do with something with another model defined, or not at all? And finally, the various conclusions that were extracted with respect to scalability and replicability procedures that were followed in these projects. So, like briefly, the conclusions that we got out of this, the most important, at least, conclusions to have out of this questionnaire were that early data collection is very, very important in order to guide, if you want, the most technical work packages towards a more scalable and replicable solution. After that, flexible SRA methodologies are needed in order, as I said, to be able to be adapted in the necessity and the particularities of each project while maintaining their robustness. And finally, a careful planning due to regulatory, technical, and market-driven challenges should be taken into consideration to achieve scalable and replicable results. So now, why in subroutine 1 there was mostly a mapping. The most important aspect is the mapping of the project's cares to the layers of the SGAM model, and of course its objectives. But here I will try to focus mostly on the importance of the procedure of the SGAM model, which is actually to facilitate the evaluation of the cares, distinguishing the most important aspect, clearly distinguishing the most important aspects of these cares. So what we did actually was to correlate its care to the various to each of the most relevant SGAM layers in order to evaluate them in a better way, in a more consistent way. So these cares were divided kind of in the corresponding cares, in the corresponding layers of the SGAM model, resulting to a matrix that you can see at the center of your screen. I don't know if you can see it clearly, but this is care 10, and this is the distinction to the 5 SGAM layers, namely component, communication, formation, function, and business layers. So in this particular case, care 10, which was the facilitator toolbox REST forecasting tool, was related mostly to communication, information, and function layers, while the business layer and the component layer were left out of it. So here in this procedure, we distinguish the main components of each care, and we further, after that, distinguish, as you can see in the first column, we have like the components of each subcare now. So this actually aims to facilitate the evaluation process of the cares. So these subcares now in the evaluation, identification, and evaluation subroutine were evaluated with respect, taking into consideration the metrics that you can see in your left-hand side. So these components, let's say these aspects to be evaluated in every subcare were related to data address, technology and communication protocols, and interoperability of the system. Each one of them has different components, plays a different role in every one of the SGAM layers. But if you look closely in this matrix, you will see that the business layer is not evaluated from this process. Actually, we followed a different process to evaluate the business layer through a pestle analysis that had been done in the context of another work package. And we tried actually to evaluate the replicability and the scalability of the business use cases of eNeuron. Unfortunately, we don't have time to analyze all of these aspects, but just as a comment, I leave it highlighted. So after the evaluation after all of this evaluation process, the result looks like this. As you can see in the center of your screen, there is a pentagon with scale like the center is 0 and the border is 1, and this actually depicts the evaluation of the subcares, or the care if you prefer, the subcares of care 6. So in every one of the SGAM layers, apart from component layer, because component layer was irrelevant, let's say, for care 6. So Care 6 was divided and evaluated in 4 out of the 5 SGAM layers, resulting to the picture, to the diagram that you can see here. So this is how the main results of our study look like. Here I would like to comment also that the KPIs that were evaluated through different processes are like distinguished with our cares, and they were evaluated with respect to different axes or aspects or domains, if you prefer, which were like technical, regulatory, environmental, and economic. Because I mentioned it because some of them are outside of the context of the SGAM model, which is more technically oriented, while at the contrary, well, of course, business model oriented as well. But for example, the environmental and economic domains are not explicitly taken into consideration in the SGAM model. Just as a comment as well. So, proceeding with the evaluation results and their representation, of course, we have already talked a little bit about all of this stuff, but here I'm going to talk a little bit about more how these results in total look like, and talk about the limiting factors that we found. So, after analyzing 18 cares for the eNeuron project, and some of them are depicted, some of the most important maybe, but all of them were important. Some of them are depicted here, and in the parentheses you can see the relevant SGAM layers. The results, the total result, let's say, of course, it cannot be restricted to that, but just to have a total sense, let's say, a universal sense of our results, you can see in the bottom line of your screen the replicability and the scalability indexes of the eNeuron project in total. Of course, as you saw in this diagram, information and communication layers. I don't know if you had the chance to see it, but just I'm going a little bit back to for a moment to see it. Information and communication layers were had the best replicability scalability indexes, the highest, while the component layer had the lowest one, close to 0. This does not mean that the technology readiness level was low. On the contrary, it was very high. But this evaluation takes highly into consideration the openness of this solution, the open access of these solutions. So here we are going to see it a little bit more detailed. So the information and communication layers actually were mostly scalable and replicable because of the detailed reporting of data exchange and open communication protocols. While on the contrary, as I mentioned, the component layer was based on closed source product and proprietary solutions. So its potential for scalability and replicability was limited, and again, taking into consideration how we perceive scalability and replicability, but based on Bridges, of course, framework. So as I already have mentioned, the low scalability and replicability doesn't mean necessarily low technological readiness, but our case, as I said, we have high technological readiness level, but scalability and replicability due to closed source solutions is limited in the component layer, while in the information and communication layers, we see higher scores. So to start concluding, now I'm going to briefly, let's say, give an overview of the general guidelines and best practice for future implementations. So to begin with, and conclude and close with the scalability and replicability subroutines of our methodology. Some of the most important parts to gain scalability and replicability is standardizing protocols and interfacing to ensure high level of integration across diverse systems. So detailed reporting and whenever it's possible, using open protocols and standardized protocols in order to ensure high level of integration across diverse systems. After that, we have to take into consideration regulatory aspects of its country, for example, or state, or whatever, in order to address the regulatory barriers in the business layer for broader application, to make possible that our solution is applicable into the more in a lot of in the most possible regulatory frameworks. After that, after having performed our analysis, it's always important to promote exchange of insight, as we have done, sharing the questionnaire, and also so we share the questionnaire to gain more insight, and also we're going to share through work package 8 mostly through the exploitation plan our results in order to make known our successes and bottlenecks of our analysis methodology, and of course solution. And as I have said earlier, mitigating the dependency on closed source products is of high importance in order to address scalability and replicability challenges according to our point of view. So, to end this presentation today, we have talked about our scalability and replicability, their definitions and their importance. Just to recapitulate, it's highly important to perform scalability and replicability analysis in our projects in order to get the best out of investments in research of European Union, and of course of national projects, and benefit the most out of the solutions that we propose for the environment and for the economy and our society. So later we mentioned key elements of our SRA, and actually we tried to analyze a little bit bridge framework, and try to highlight why it's important to have a robust framework but also adaptable. And then, of course, we mentioned our adaptations, which were the questionnaire that we added mostly to gain the insights that I mentioned, and after kind of separating the evaluation of the KPIs, and we closed today's presentation with presenting the results evaluation and the representation while proposing best practices and guidelines. And here at the end, I would like to highlight, as you can show, that there are always challenges to establish a universal SRA, because every project is unique, has its own particularities. But if something would be of high importance out of this presentation, I think that it would be the importance of standardizing not only communication protocols and data exchanging formats, for example, and open access tools, but also establishing a universal kind of SRA framework, so that we can decide and guide better our solutions and projects. to perform, to have more scale, to have higher scalability and replicability indexes. So thank you very much for your attendance. And if you have any question, I think that we have a Q&A section so that everyone would be able to share thoughts, doubts, or any questions. And if you want, if you have anything else that you want to comment, I haven't my email here, but I can share it in the chat if you want to contact me later. Thank you very much.
Thank you very much, Dimitrios, for your insightful presentation. As you were saying, if any of you has any question concerning what has been presented today so far, we have a Q&A session coming soon.